Okay, so I've got to work out this without a calculator. So I'm going to begin with the first fraction, which is 5 over root 3. So what I'm going to do, I'm going to rationalise it, because to take away fractions it's much easier when the denominator is not a third. So to rationalise, we multiply the top and bottom by root 3. So that's exactly what I'm going to do, showing all my working out. So 5 times root 3 we write as 5 root 3. Root 3 times root 3 is root 9, which is 3. So we get a mark just for doing that. Now the second fraction is improper. It's mixed. We need to make it improper. So we need to know that 6 3/4 is the same as 27 quarters. Now how did I know that? Well, I know that 6 is 24 quarters. And I've got 3/4, which makes 27 overall. Or some people just do 6 times 4. Add on 3, and that gives you the numerator there. Right, the square root of 27, we'll deal with that in a minute. The square root of 4 I know is 2. Now let's simplify root 27. Think of two numbers that multiply to give 27, but one of them's got to be a square number. So it's root 9, root 3, and the denominator is 2. Now the square root of 9 we know is 3, and we've got root 3 here as well. So by simplifying the numerator, I've changed the second fraction. So what I've got to work out is I've got to work out 5 root 3 over 3, subtract 3 root 3 over 2. So to subtract fractions, they've got to have a common denominator. So that common denominator is going to be 6. So I'm going to double the first one. I'm going to triple the second one. Then I can actually take away these fractions. So if I double the first one, I get 10 lots of root 3 over 6, and if I triple the second one I get 9 lots of root 3 over 6. And I'm going to take them away. So 10 lots of root 3 take away 9 lot of root 3 is 1 lot of root 3 over 6. Now if we look, it does want it in this form, so I suppose really we should write it as a 6th root 3. So it's really clear that k is a 6th. Right, so for 24 we've got a recurring decimal. So I can see it's, I can see two decimal values. So what I'm going to do first is I'm going to let x equal this decimal. So it's going to equal 0. I'm going to write it out in the long way, so 0.28888, and those 8's gone forever. Now what I'm going to do is I'm going to multiply that by 100 to start with. I can see two different digits, if you like, in the decimal. So I'm going to multiply by 100 to get 28.88 recurring. I'm also going to multiply it by 10x, and if you don't know why, you'll see why in a moment. So if I multiply the original x by 10, I get 2.888 recurring. So now you can see by multiplying it by 100 and multiplying by 10, it results in the recurring part being equal on either side of the decimal here. So if I actually subtract these away from each other, so 100x take away 10x gives us 90 lots of x. 28.8 recurring take away 2.8 recurring gives us 26. So x is 26 over 90. That's super, but it does say in the simplest form. So what I'm going to do is I'm going to half the numerator and the denominator, and 13's prime. I can't simplify it anymore. Job done. So here we have a Venn diagram question, and we have 295 students at a college. And firstly, it's pretty standard. Work out probability that the student takes art. Now these students take art, just art, but so do these students. They take art as well as geography, but they do take art. So how many students take art? Well, in the art part, we have 25 add 14. So 25 add 14 gives us 39. So the probability the student takes art is written as 39 out of 295. No need to simplify the fraction here, so there's one mark. Now the second one, it says one student who takes geography is chosen at random. So we know we're looking at these students just here. These students, the geography students, that's who we're looking at. Work out probability the student also takes art. So how many of these geographers also take art? 14. How many students were we looking at? What's it out of? It's out of 14 add 29. So the answer we're looking for this part is 14 out of 43. And the part C is now involving algebra. So X is defined to be the number of students who take both history and English. So the first sort of sentence down here, 1/2 of the students who take history also take English. So X here is 1/2 of the students who take history who also take English. So X here is the same. 1/2 of the students who take history also take English. So this also must be X, because altogether 2X lots of students take history. Now for this part, the number who take English is twice the number who take history. Now I know 2X in total take history, so I know that English has got to be 4X, twice that. Now we already have X here, so 3X must be just here. Work out the value of X. Now we know how many students are in the college, we know how many students don't take either history or English, so now we can write an equation. So we can say that X add 3X add 125 has got to equal 295. So if we simplify the algebra, we have 5X add 125 is equal to 295. Okay, so then we can see that we have 5X equals, so subtract the 125 gives 170, divide by 5 gives 34, so the value of X is 34.